Hello again. We've been factoring. We factored we factored x squared plus bx plus c. We factored ax squared plus bx plus c. We factored GCF. And now we're going to factor special products. And actually these I like, and they're usually pretty pleasant for my students because they can notice a pattern, which is fantastic because then they think it's easier and everybody's a little bit happier. It's not something that students necessarily have to struggle with as much, which of course makes you feel a lot better when you do something a lot quicker than you're supposed to. Last section though, a little difficult, but you kind of have to go through it, and it's not so bad once you practice it. It really isn't. Like, I do most of my head, and I don't do them the way that I showed you anymore, but I used to do that, and then my mind got a little bit sharper with it, so then I started doing other things. Well, what we're going to do is we're going to factor perfect squares and trinomials. And we're going to factor special types of trinomial products, and we're going to factor the difference of two perfect squares. Now, here's how I just show my students. If you have two terms when you're factoring, and there's a difference, let me say that again. If there's a difference of two terms, and they're both perfect squares, that means that something times something equals x squared, the same thing, and something times something equals 16, pardon me, the same thing, and then it's just the difference of two perfect squares. That's all there is to it. For instance, what times what, and it has to be the same thing, equals x squared, x and x. What times what equals 16? 4 and 4. The last term is negative, so that means that one's a plus, one's a minus, x, 4, 4. Finito. Done. Way better than the ax squared plus bx plus c problems that I showed you before. And you can check. 4 times x is 4x. X times negative 4 is negative 4x. When you add them up, 0x. There is no middle term. That's hence 0x. And you're done. X plus 4, x minus 4. This only works for the difference of two perfect squares. If there's an addition sign in between it, it won't work. And if none of them, and if one of the two isn't a perfect square, that strategy doesn't work. This is a special type of product. And basically it's x plus a number, x minus a number, or variable something, variable something. But one's a plus, one's a minus. Same thing here. Is this a difference of two perfect squares? And the answer is yes. First of all, it's a difference. There's two terms. 25 is perfect because 5 times 5 is 25. 64 is perfect because 8 times 8 is perfect. X times x is x squared. So this is 5x and 5x. This one's 8 and 8. And since the last term is negative, one's a plus, one's a minus. Five x. 5x, 8, 8. Finito. Done. 8 times 5x is 40, plus 5x times negative 8, which is negative 40, that's 0x. It cancels out the middle term. So, you just factored. If it was an equation, then you'd have to set the zero product property, etc. The last one is trinomials that happen to work out pleasantly. You don't have to use that really nasty looking method that we used on this specific one because it's a, well, I'll show you. It'll make more sense when you see it. See, what times what is x squared, x and x? What times what is 49, 7 and 7? It only works when that's the case, when the last term and the first term in a specific trinomial are perfect. The last term is positive, but the middle term is negative, which means the signs are both negative. X, 7, 7. Done. Next one. You check to see if it's in order from highest degree to lowest degree or in proper form. I can't even tell looking at this monstrosity. But I can tell it has no GCF. You can take a 4 out of here, but you can't take a number out of here. You can take an x, but there's no x there. Y, no y there. So there's nothing you can do besides just factoring it out. Now the last sign is positive, and the middle term is positive, so positive, positive. What times what is 4x squared? 2x times 2x. What times what is y squared? Y times y. Now, like I said, it only works when the first term and the last term work out perfectly like that. If it doesn't, yeah, you got to figure out a different method. One of the different methods that I happened to show you before would be perfect. So 2x, 2x, y and y, done. You just factored perfect squares and products of trinomials with perfect squares of them too. So those are special products. A lot more pleasant than the last two types of factoring that we did, but give and take. You know, sometimes you just kind of have to kind of go along. That said, I hope that was very helpful in terms of factoring. Have a good day for now. Goodbye.